Excel Mechanics 1, collisions in one dimension, loss of energy due to impact. In a collision between two objects, we assume there's no external force acting and we consider the momentum of the objects, which will depend on their masses and velocities. There will be no loss of momentum, and the total momentum before the collision will be the same as that afterwards. However, there is likely to be a loss of kinetic energy possessed by the objects. This loss of kinetic energy is transformed into other forms of energy such as heat and sound. The amount of kinetic energy lost is influenced by the elasticity of the collision. We know the coefficient of restitution is dimensionless and between 0 and 1, and we can consider the change in kinetic energy of both objects. So the change in kinetic energy is the final kinetic energy minus the initial kinetic energy. Kinetic energy is a scalar quantity, and if we get a negative answer, it indicates a loss of kinetic energy. So during a collision where we assume there are no other external forces acting, can we calculate the change in kinetic energy of this system? So we know the velocities before and after the collision, so now we can find the kinetic energy change. And if we're doing the change in kinetic energy, we've got to do final kinetic take away the initial kinetic. So the final kinetic energy, we've got half times 6 kilogram moving at 3 meters per second, and we've got a half of 1 kilogram moving at 6 meters per second, so that's 6 squared. Take off the initial kinetic energy, so we've got half 6 kilograms, and that's moving at 4 meters per second, so that's 4 squared, and the other one was at rest, so that's a 0. So that gives us a change in kinetic energy of minus 3 joules. In other words, 3 joules of kinetic energy have been lost. Okay, so we either say the change is minus 3 joules or 3 joules of kinetic energy have been lost. So in this example, we have a negative velocity, so we've got an arrow to the right, but the actual velocity is a negative value. So let's have a go at doing kinetic energy change here and see if that makes any difference. So final kinetic energy, so we've got a half, 3 kilograms, and because energy is a scalar quantity and because we're going to square this value, it doesn't really matter whether you call it 2 or minus 2. So even if I put minus 2 in there, it will still give me 4. So let's do the kinetic energy, the other one. So we've got half times 4 times 4 squared, and now I've got to take off the initial kinetic energy. So that's a half times 3 times 6 squared, and we add a half times 4 times 2 squared. And even though that arrow is pointing backwards, it doesn't affect the kinetic energy. It's still 2 squared. And that gives me a kinetic energy change of minus 24 joules of kinetic energy. In other words, i.e., this is a loss of 24 joules. That's what the negative answer is telling me. We've lost 24 joules of kinetic energy. And you can see the full work in there. So I could have just used that velocity. I could have called the speed 2 and got the same answer. So during this collision, we are going to assume there are no external forces, but these two particles coalesce. They're going to stick together. We need to calculate the change in kinetic energy. So if I did a momentum problem on this, I would find that they're going to move to the right with a given speed of 0.8 meters per second, and since they've coalesced, E must be 0, so I know E if needed. So now if we look at the kinetic energy change, remember it's final kinetic, take away initial kinetic, so the final kinetic energy is we've got a half times, and they're stuck together, so the mass is 5, and they're both moving at 0.8, so that's 0.8 squared. Take away the initial kinetic energy, so that was a half times 3, and that was moving at 4 meters per second, so that's squared. And the other one was a half times 2, and even though it was going backwards, it's still its speed squared, which is 4 squared, which gives me a change in kinetic energy of minus 38.4 joules. So here it's lost nearly all its kinetic energy because they have stuck together. So most of the kinetic energy has been lost, and it's worth pointing out in the previous questions and this question, momentum has been conserved. So although we can have conservation of momentum, we nearly always will lose kinetic energy. And again, you can see the method in full. In the next session, we're going to be looking at successive impacts of spheres.